ladies and gentlemen who present at the operation room of Faculty of Agriculture Technology, and also the participant who joined via Zoom meeting. Welcome to the guest lecture of Professor Fahrettin Goyus, the Vice Rector and also Professor of Food Engineering Department of the Gaziantep University. So in a minute, the guest lecture will be start, and this guest lecture will be moderated by the faculty member of the Faculty of Agricultural Technology UGM, which is Dr. Viameta Ayu Perwandari. So the time I would like to convey to Dr. Viameta.
Thank you, Mas Sakti. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Warm greetings to all the lecturers, the students, and all the participants who join online or also on site in this room. Thank you for being here and for your enthusiasm in attending this guest lecture today. In today's topic, it is both timely and also highly relevant to the field of food processing and sustainability. The guest lecture entitled The Novel Technologies in Extraction of Valuable Components from Food Processing Waste. And to be honest, I had the pleasure of meeting Prof. Fahrettin during my visit in Gaziantep University, which is a memorable experience to me. And it is a great honor now to welcome him in person in this occasion as our guest speaker, Prof. Fahrettin Goyus. I hope I'm pronouncing your name correctly. Yes, and Prof. Fahrettin is a leading expert in food technology and process engineering. He completed his doctoral degrees in food science in University of Leeds, United Kingdom. And since 1995, he has been actively involved in academic leadership at Gaziantep University, where he currently serves as professor in Department of Food Engineering, and as well as now appointed as a vice rector at Gaziantep University, Turkey. And in today's lectures, he will deliver around 30 minutes of presentations, sharing his research on advanced and sustainable extraction methods that allow us to extract valuable components from food processing byproduct. And after the presentation, there will be a discussion sessions for those who would like to ask questions, and also we can have opportunity to explore the topics further. And without further ado, please join me in welcoming Prof. Fahrettin. The screen and time is yours.
Thank you very much. You're very welcome to my presentation. It's a great honor for me to be here in your esteemed University of Gadjah Mada, and I am very happy to be together with you in here. My topic is the novel technologies in extraction of the valuable components from the food processing waste. It is basically what we are studying in our laboratory. And in the last few years, what we did, I will just summarize the topics we studied. More than going into the details of each topic, I will just give the little what we are doing in my laboratory. Shall we go to the next slide? Yes, it is my presentation topic. We will be starting with the olive pomace, grapefruit peels, pistachio byproducts, carrot pomace, and in the last section, we are dealing with a new technology. We are the first in the world actually combining the high pressure carbon dioxide and the microwave together in this system. I will be just giving some examples of this system to you. Yes, please go on to the olive pomace presentation. Yes. I am not sure you are familiar or not with the olive pomace oil and the olive oil processing, because you are basically dealing with the palm oil and the palm fruit in here. And olive oil is one of the fruit oil, and we get around 200 kilogram of the olive oil from the 1 tons of the olive. It is just a processing line to give an idea how much waste we get from the olive processing line. And the waste, we call it as the crude olive pomace. And it has still some oil, but this oil is not a good quality oil. And especially after the drying process, the oil quality will be just decreased in a bad way. So that is why, and also the separation of this oil from the pomace is difficult. So we apply a solvent extraction for that purpose in the further process. The first olive oil is it is called mostly a virgin olive oil, and it has been just sold in a high price. But the olive pomace oil, which is a secondary oil obtained from the olive pomace, is not being used directly as a food oil. It should be processed, it should be refined. And after the refining process, we call it as the refined olive pomace oil. And it is still not like the olive oil, virgin olive oil. Its price is still quite low compared to the olive oil because it has been refined and it is not a cold pressed oil anymore. And during that time, we apply a very high energy during the drying and also during the extraction processes. But anyway, we get the refined olive pomace oil. How we can evaluate, how we can valorize this olive oil? When we were discussing that, we just tried to find a solution and to find some different products from that olive pomace oil. Can you just pass to the next slide? Yes, for that purpose, we just discussed the basic triglycerides of the olive oil. It is very similar in terms of their triglyceride structure. Olein, oleic is the basic component, triolein means. And we just try to make a cocoa butter equivalent oil. Can we pass to the next slide, please? Yes, in that respect, what we did, we just used the 1,3 specific lipases just to change the 1,3 positions of the oleins, 3 oleins, and to get the high SN2 oleic acid content. Can we just go, please? Yeah, it is the reaction what we performed. Just we bound simply palmitic acid and stearic acid in different combinations, and to obtain the cocoa butter-like fat, which is POP, POS, and the SOS basically in its main structure. And it was very successful, and we got the result with the olive pomace oil to the palmitic acid and the stearic acid combinations, 1, 2, 6 combinations was the best combination with a temperature of 45 degrees centigrade and 3 hours. And in the hexane solvent environment, we got that particular product. Yes, we can pass. Another, the citrus fruit. Citrus fruits are also very common fruits we process. And basically, we process them for the orange juice production or the lemon juice production or the grapefruit production in our country. And for this purpose, when you use around 2 tons of the fruits, you get around 1 ton of the peel waste. And other than the peel waste, we get around 10 kilograms of the seeds. From the different varieties, definitely it can be changing the peel waste quantity and the seed quantity, definitely. And in some cases, we dry this peel waste and use it as the feed for the animals. And it is the most commonest way. But instead of that, as we are aware that it is very rich in its pectin content and also in the limonene content. Can we just go, please? And so that for that reason, we just try to extract the pectin and limonene from the citrus base. Actually, there are many different processes during the orange juice production. In some of the processes, we use the peel as a constituent of the fruit juice. And it is a fruit juice concentrate, but rich in its peel content. So in that respect, there is no pectin in the further waste of the orange processing. But in most of the processes, we get around 50% of the waste, which is peel, and it is very rich in its pectin content. Can we just go, please? Yes. So it is very common to extract the pectin in the basic conventional techniques, but it needs to dry the peel first in the conventional techniques. Instead of that, we use the peel directly without drying in a microwave environment, and we get the pectin in an easy way. So this just gives us the opportunity that we just eliminate the drying process of the peel. And other than that, in the same system, we extract also in an open microwave system, we extract the D-limonene in a sequential process. Yes, please. And other than the pectin and the limonene, we also studied the production of the materials which can be used in the cleaning of the wastewater processes of the cloth industry. For the dyeing of the clothes, it is very rich in its heavy metals. So for that purpose, we produced a carbon product, and this carbon product has been produced again with the microwave system, and directly processing of the grapefruit peel, and in its wet form, we produce the hydrochar, and this hydrochar has been combined with some metals, and we just use it in the extraction of the calcium solutions. Yes, please. And another waste we use is the pistachio production waste. And pistachio, as you see in here, I am not sure you have seen the pistachio in its fresh form or not, but pistachio has two layers. And the outer layer, which is called as the hull, and it is red in its color when it has been just matured completely. And we have another layer, which is the shell. And shell is basically very rich in its cellulose, hemicellulose, and lignin content. And what we do, we just burn when it has been dried. Even you cannot burn the hull, because hull is very rich in its resin content. So it caused the problems during the burning process. That's why we decided to extract some valuable components from both the hull and the shell. Can we go, please? And we extracted the phenolic compounds first, again by the microwave-assisted extraction system. We call it as the MASE, microwave-assisted system. And it was very successful, and the amount of the phenolic compounds has been increased with the increase in power, and the extraction is very short in the microwave systems. Instead of hours of the extraction, we get the target extract in few minutes in most of the cases. Yes, we can go, please. And also, we do just obtain the different layers of the different layers of the material from the shell. Shell, as I mentioned, is very rich in its cellulose, hemicellulose, and lignin content. And what we did, again, with the microwave environment, in presence of the alkaline systems, we separated the liquid and the solid fractions. Liquid fraction is very rich in its hemicellulose content, and solid fraction is rich in its cellulose content. So what was our main aim? Our main aim is, in the beginning, was to just separate the cellulose and hemicellulose. Hemicellulose can be used as one of the main constituents as a prebiotics. And cellulose can be further processed for the glucose production and also from the glucose into some other products. But during that time, we noticed that hemicellulose also very rich in its xylose content. So it is basically xylo-oligosaccharides. More than the arabinose, there is very little arabinose, and it is basically made up of from the xylo-oligosaccharides. That's why this means that it is basically xylose. So that's why in the further research, we concentrated on the hemicellulose and hemicellulose components in the further research. Yes, we can go, please. And we did the similar studies also by combining the ultrasound and the microwave to increase the yield of the hemicellulose and the cellulose at the same time. And as you see in here, the processes are very short, even if it has been combined, ultrasound and the microwave. And the combined system, again, just gave us the higher efficiencies and also shorter times of the processings. But as you notice that in all these processes, we are using an alkaline, or in the processes of the extraction or the breakdown of the cellulosic components, you should be using either the alkaline systems or the acidic systems. I will come to an important point later on. That's why I am emphasizing the use of the sodium hydroxide or the acid systems in the breakdown of the hemicellulose and cellulose structures. Yes, we can go, please. Another study was concentrated on the carrot juice processing waste, because Turkey is also a very important processor and the producer of the carrots. Not only that carrot, also the black carrot is one of the components we produce. That's why in the last years also we concentrated on the black carrot, because it is very rich in its anthocyanin contents, and we extract the anthocyanins and pectins at the same time from the black carrot as well. Yes, in that respect, our main component is the carrot waste, and beta carotene of the carrot waste was our main target component. And instead of extracting the beta carotene with the different types of solvents, we used the oil. And this oil was a special oil, flaxseed oil. It is very high in its unsaturation. So our main aim was not only to extract the beta carotene or the carotenoids in general, and also to produce an unsaturated system rich in its carotene content, because we used it further in an encapsulation process. So in this process, we did it in a microwave system. Again, you can be expecting that in a microwave system, the oil quality can be reduced. Yes, we were expecting that, but the time was very short. That is why the product was very good in its acidity and peroxide levels. So it was acceptable, that process, to extract the carotenoids into the oil medium. Yes, these are some characteristics of the material we obtained, as you see that the oil basically has a very low beta carotene content, and we just enriched it with the beta carotene of the carrot pomace. Yes. Also, its total phenolic content has been increased sharply with the addition of the carotenes. And as you see in here, after the extraction of the carotene into the olive medium, we prepared the different type of the emulsions, and these emulsions were characterized with their particle size and also with their rheological properties. And then, yes, please, we just go away for the production of the encapsulated products with these flaxseed oil carotene complexes. And this technique also is a quite new technique. It is a known technique, but it is not very common. It has been called as the spray freezing process. You are just spraying your material into a liquid nitrogen, and it has been frozen over there. And after frozen materials, you just take it into the freeze dryer and dry your samples. And by this way, we got a very good encapsulation, and different techniques of the encapsulation has been applied in here. And one of them was the spray freeze drying. We used directly spray drying, and also the basic drying techniques also have been applied. And spray freeze drying was a very, very successful process, and we obtained it. And basically, what we tried in here, our main idea is to bring the wax and pectin together in the encapsulation material. As you know, the peel of the apple is the wax and pectin, and it is a very good protector for the apple. So our idea has been designed according to that idea, and we just tried to bring the wax and pectin together in our encapsulation medium. Yes, please. And lastly, what we just tried to do, we decided to bring these systems means the carbon dioxide and the microwave system together. Because in the applications up to now, we were applying the alkaline solutions or the acidic solutions in the breakdown of the materials, in the extraction of the pectin, or in the breakdown of the cellulose and hemicellulose. But instead of that harsh chemicals, we use the carbon dioxide as a medium, because in a high pressure system, carbon dioxide has been dissolved in the water, and pH has been decreased up to 2.8. And it was a very good medium for us for the breakdown of the cellulose from hemicellulose. And by this way, without using any chemicals, we had a chance to break down the cellulose from the hemicellulose. And with this technique, we basically reduced the extraction time with rapid heating. Some of them are basic microwave characteristics, improved solvent to solid matrix penetration, and it has improved the extraction yield. We have a higher selectivity with this technique, better quality of the target compounds, because a very good separation has been performed, and also inhibition of enzymes to prevent the oxidation process, because we have a carbon dioxide medium and it is free from the oxygen. So there is no risk of the enzyme activities, and the process temperature is increasing very sharply in the process. Yes, can we go? It is our system. We combined the carbon dioxide into the microwave system. First, we are feeding the carbon dioxide in the system at around 30 atmosphere, and the dissolved carbon dioxide as the carbonic acid in the water, just creating a medium of the acid around pH of the 2.8, and we just start to process in the system, apply the microwave, increase the temperature, and we get the normal processing of the microwave in here. And when the process has been finished, when you open the door of the tank, the carbon dioxide has been released back again, so it is free from any chemicals. So it was the idea what we managed and brought together, carbon dioxide and the microwave. And what we did with this system, can we go please? Yes, we extracted the flavonoids such as the grapefruit peel flavonoids have been extracted. Yes, please. And basically, it was a first trial, one of the first trials, and we were quite successful in the extraction of the flavonoid extraction. Yes, please. And you see that in here, the extraction time has been reduced from the 190 minutes to the 14 minutes in the extraction system, microwave extraction system, compared to the conventional extraction. And extraction temperature has been increased, but it was a short time. So that's why it did not give any damage to the flavonoids during that time. And also we used an extraction yield has been increased from 43 to 55% on the dry basis. Yes, please. Yeah, and the extracted component has a very high flavonoid content, phenolic content, and it is also antioxidant activities are quite better compared to the conventional extraction techniques. Yes, we can go. Yes, the extracted components have been analyzed and they have been defined. Again, the microwave system gave us higher concentrations of the specific components as well. Yes, please. And another extraction was the extraction of the peel again from the grapefruit, and it was the pectin. And as I mentioned in my presentation earlier, we applied the pectin extraction in a microwave system with the alkaline, but in this system, without any chemical, we did the extraction process and it was much more successful compared to the alkaline process. And according to the also conventional extraction methods, it was very successful. Both in the time, you see that time has been decreased from 180 to 10 minutes. And also we increased the extraction yield from 24 to 27 around. And other than that, the quality of pectin has been changed quite a lot. Can we go, please? And you see in here, the pectin extracted has a better quality other than the yield is galactonic acid content, and it is equivalent weight is much more better, and also it is color characteristics are much more better, and the pectin slurry we prepared has a better viscosity characteristics prepared by the microwave extracted technique. So it was unique to be used in the industry. Yes, please. And also it has been used in the jam production, and it was very successfully in the processing and the production of the different types of the food products like jam. Yes, please. And later on, as I mentioned, in the first steps of the shell processing, we aim to get the hemicellulose. But as I mentioned earlier, we noticed that this hemicellulose is very rich in its xylose contents, and this xylose can be used in further processes if we just get the xylose in a high quantity. Instead of our aim in here was not this time to produce the xylo-oligosaccharides. Instead of that, we aim to get the xylose in the monomers. And we change the process conditions and we get the xylose, the hemicellulose monomers in the processing. And after getting the xylose, this xylose has been used in the production of the xylitol in the further step. And we get some definitely inert products during the separation process, some furfural, some HMF, and some acids definitely, but they have been just cleaned very easily with some applications of the active carbon and the simple mixing processes, and we obtained the product. And regarding to this study, we lastly have written a new project together with a China group from the Shanghai University, and we are getting the xylose in our process, and they will be processing the obtained sugars in the production of the many different biotechnological products. Basically, methane has been aimed in the biotechnological process. I hope this project application is going to be successful. We are waiting the results of this application. Yes, please. Yeah, this is the result of the microwave high pressure carbon dioxide processing, and you see the xylose yield in the extraction process and in the breakdown process. Yes, please. And the obtained material, as I mentioned, is having some impurities such as acetic acid and the furfural. That's why it was critical, because during the high temperature processes, definitely some Maillard reactions are occurring during the process, and they should be followed during the process. Yes, the amounts of the acetic acid and the furfural was higher in some way, but the process was very successful. And we just did a control study also only with the nitrogen instead of the carbon dioxide system. Only with the nitrogen we tried. If the carbon dioxide is not available, what is going to happen? And our yield, as you see that, our yield has been decreased. So the carbon dioxide is a very effective component, and not only our yield, also the impurities have been increased. Our main aim is to increase the yield and decrease the impurities. So that's why the high pressure carbon dioxide and microwave system was quite successful. Yes, please. Yes, and also we extracted the beta glucan with a similar technique. Can we go? As you know, maybe I should be talking about a little bit about the beta glucan. Beta glucan is also a polysaccharide, which is available in the barley, which is growing quite a lot in Turkey. And it is not a waste process, actually, but beta glucan is a very valuable component. It has been suggested to consume a certain amount of the beta glucan to increase the immune level of the human being. That's why we concentrated together with a nutritionist. We concentrated on the products to produce different types of the products which are rich in its beta glucan content. And later on, we decided how we can extract the beta glucan from the barley and get a higher amount of the beta glucan to be used in any kind of the product. Yes, please. Yes, the beta glucan also extracted with the microwave assisted pressurized carbon dioxide system. You see that purity and the yield has been increased very sharply, and the yield is increasing and also purity is increasing. It is very critical. You can increase your yield, but it could be containing something else. In all kind of the extraction systems, you should be just dealing with your main target component. You can be extracting the pectin, but how much of it is a real pectin? And you are extracting the beta glucan, but how much of it is a real beta glucan? So it is very critical, and we just have seen that both the yield and the purity has been increased with the microwave carbon dioxide system. Yes, please. And also the obtained beta glucan is the characteristic of the beta glucan is very critical. So that's why we just studied all possible characteristics of the beta glucan, because it is only valuable if it has a certain size. This means that certain molecular weight. And that's why they have been all studied in the study. Yes, please. And I'd like to thank to my colleagues, Derya, Aysel, and Neval, and also to you for listening me for my presentation. Thank you very much. If you have any question, I can be answering your questions on time.
Yes, thank you very much, Professor Fahrettin, for inspiring and thought-provoking lectures. Now we will open the floor of questions. So any of you who would like to ask question, please raise hand and mention your name. Maybe two for on-site and one perhaps for the online participants. Yes, Prof. Jusnul, please.
Okay, thank you for very interesting presentation. Thus, I would like to ask, do you have experience to extract bioactive material from non-polar waste?
Non-polar?
Non-polar waste, for example, non-polar oil or waste.
Waste. All right, I see. We did not study the oil systems. Mostly, as you see that we use the fruit systems, and they are basically the polar systems. But it is not very common in our studies. I mean, we extracted earlier from the pistachio shell oil, and also into the oil we extracted the phenolic compounds. But we are not very familiar from the non-polar systems. You are asking basically the oil. How can you get the phenolics from the oil, for example? Do you mean that?
We interested to extract beta-carotene from palm oil.
All right. Yes.
Such kind of maybe to have experience, for example, bioactive compound from olive oil, for example.
Yeah, we are not experienced on it. Yes, no. Actually, we are not studying on the extraction of the phenolics. Basically, we are trying to add the phenolics into the olive oil, and in terms of we are trying to keep the phenolic contents of the olive oil high. All right, that's why we never try to separate the phenolics from the olive oil. I mean, it is not the area of our study, at least.
Okay, yes. Thank you.
Thank you.
Thank you. Any other questions? Is there anyone who joined online ask the questions? Okay, then maybe I can. I have one question. So you show that microwave assisted extraction is beneficial to break down the hemicellulose and also the cellulose part. Do you think it is possible to also apply the microwave assisted extraction on the legume? that we would like to extract the pectin. So because we have a problem with the legume that has been stored for a long time, and it caused a hard to cook problem, and maybe microwave assisted extraction could help to eliminate in the form of legume, not in the form of powder, and so that the cooking time perhaps can be reduced.
Yeah, possibly. Yeah, I mean, if you do not apply a very harsh process because you would like to keep the legume as legume, but you would like to eliminate just some part of it. Yeah, it is possible, but you should be careful that basically in our hand already a damaged material is available. And it doesn't matter how you damage this one more time, it is not a problem. But in your case, you like to extract something from the legumes, and legumes should be still just keeping the characteristics of the legumes. But as I said, if you apply a very mild processes to the legumes, you can extract this undesirable components. Yes, sure. Sure. Yes.
Thank you.
You're welcome.
If there is no other question, then yes, please.
Yes, sure. Please.
Yeah. You mentioned that you also synthesize xylo-oligosaccharides.
Yes.
Did you characterize and apply it or check the functional properties?
Yeah. At the moment, what we are trying, we didn't define the type of xylo-oligosaccharides in our first trials, but we have at the moment a new project. It is a TÜBİTAK project again. And in that particular product, because, you know, the xylobiose, xylotriose, xylotetrose, we would like to get the 2, 3, or 4 members of the xyloses together. And we just started to study that subject, and we are going to get these basic xylobiose, xylotriose, and the xylotetrose in our trials. Again, by using the different conditions, we are going to get it, and we are going to combine it with the beta-carotene, but we didn't define in our earlier studies the xylo-oligosaccharide. We just know that it is the xylo-oligosaccharide, but we are not very sure how it is prebiotic activities, how it is size. We are not familiar at the moment with it. Yes, thank you. Mannans, yes. Oligosaccharides. So you should be defined for the prebiotic purposes. You should know the size of the material as well. Yes. Yes. Yes. Sure. Sure. Yes. Yes. Definitely. Definitely. Yes. Prebiotic characteristics. We can produce the material, and you can just follow the prebiotic characteristics. Yes. Sure. Sure. Thank you. Thank you very much.
Once more, maybe.
Yeah, it's over there.
Once more.
There are a few more. Good.
Okay. Thank you. Based on your experience to accelerate the extraction using microwave, how about the stabilization of its compounds? How long do we use? Should we use microwave to avoid the degradation of its compounds?
You mean?
Maybe how long should we use the microwave to avoid the degradation of its compound? Is your and at your experience to accelerate the extraction, how about the stabilization of its compound that you have that you want to gain that you want to get?
If you are asking, for example, we use the oil, all right?
No, such as bioactive compounds.
Yeah, all right. If it is longer than the 30 minutes, all right?
Only 30 minutes.
Yes.
No more.
Longer than 30 minutes.
No more.
Yes.
Okay.
Definitely bioactive compounds have been just decreasing. Yes.
Okay.
Yes. Yeah. And it is also dependent on the pressure and the temperature of the conditions. Yes, all right. And also it is dependent on the availability of the oxygen or the inert gas. There are many different factors, but basically if you apply more than 30 minutes, you can degrade the phenolic compounds. Yes.
Okay,
Yes,
thank you.
sure. Yes, because I mean, in our laboratory, no, but microwave systems have been developed. Tons of the processing making devices are available in the industry now with the microwave. Yes, sure. Not microwave carbon dioxide, but with the microwave, there are some devices. Yes, yes. You're welcome.
Yeah, I see there is one
Yes, please.
student.
From your extract, if you have experience for the purification, can you mention to us what is the effective purification technique you have ever been before like this?
Purification of what?
Like purification, the beta carotene or anything else that have relation to bioactive compound.
Basically, definitely to get the pure materials from the phenolics is not very easy, all right? But you can use many different techniques. For example, TLC, thin layer chromatographies, it can be used, or you can use the different type of the superfluid extraction techniques for the separation of the phenolics. It is what we do. We use the supercritical fluid extraction for the separation of a specific, for example, if you are concentrating on a specific component, you can be using the different conditions of the supercritical fluid extraction, carbon dioxide means. In the supercritical fluid extraction, you can just purify the aimed target phenolic compounds from the others. Otherwise, as you mentioned, we are extracting the whole material together. We have 5, 7, 10, 11 different types of the phenolics. But if you decide which one should be purified, according to that, you can just make the conditions probable, and you can apply many different techniques. You can use the very conventional techniques, solvent extraction techniques, but newly, I suggest the supercritical fluid extraction. It's the good technique for the separation of the phenolics. Yes.
Okay, thank you. Actually, I have been extract the anthocyanin from the rambutan peel waste rambutan peels. So the next step is purification using the Sepadex. So I think I not enough. The purity is not higher like we are expected.
You are expecting.
Yeah.
In that case, what you can do, you can use the different types of the column materials as well. All right. If it is anthocyanin, different type of the column materials. You can be just packing the column, and you can be just passing your material from the column, and you are just separating them into the different parts. And one of them is your target material. The column material is, you can be choosing any kind, Dovex or any other kind of the column material can make your job easily. Yes, sure.
Okay, thank you.
You're welcome.
Okay, thank you very much. Due to our time limit, therefore,
Yes.
I'd like to conclude this discussion session.
Yes.
Again, thank you so much.
You're welcome.
Lecturers.
Thank you. Thank you very much for being here.
Also,
Yes.
thank you for all the attendance, the lecturers, the students, for your attendance, and also for your engaging in the question and discussion session. We hope that today's lecture is not only broaden our knowledge, but also inspires us to further research collaboration in the future.
Yes, sure.
Yes,
Thank
and
you.
then
Thank
I
you very
would
much.
like to officially close today's session. Thank you once again for your time. Wassalamualaikum warahmatullahi wabarakatuh.